Welcome everybody to Circuit Launch and the Making It Big Experts Talk Manufacturing Success. This series is a hardware collective series. You can find out more about the series at hardwarecollective.co. It is a group of our wonderful hardware spaces here in the Bay Area, including Port Labs, Circuit Launch Us, Studio 45, and Silicon Valley in your pocket. This series is also sponsored by our wonderful Kickstarter, and we're excited to have you guys all here. Thank you for coming and enjoying some good barbecue. Thank you guys for coming. Alex is our wonderful CEO and chef. I'd like everybody to give him a big round of applause for amazing. Oh yes, he'll make some amazing caipirinhas for you later when he gets not so busy. And for those of you guys who have not been to Circuit Launch, I guess we'll introduce a little bit about who we are. Circuit Launch is a space here that is all about hardware and robotics. We are an open ecosystem of companies. We have over 70 companies here. And if you would like to work in hardware or design something, build something, or just network with our great community, come check us out at circuitlaunch.com and come work with us. We'd love to see you in the space. The community is what is exciting here. And we'd love to have you guys also check out a lot of our the other spaces. Port Labs right over in Oakland, amazing company. You can mention to Kyle if you're interested in checking them out. They're down in downtown Oakland. And Studio 45, Nate, who's over in San Francisco, another amazing hardware space. And then Silicon Valley in your pocket is the group that actually is known for the Hero Note, which is an amazing investment note for hardware. You can check out more on our website. We just actually posted their last event on our YouTube page. So thank you guys all. I'd love to start with by introducing our guests tonight, as well as myself. I'm Dan O'Mara, as a founder here at Circuit Launch. I'll be your moderator tonight. This is Olivier Leroux, and he is a renowned expert in operational efficiency, specializing in the Toyota production system, including significant roles with Toyota Supplier Support Center in North America, Operations Management Consulting Division in Japan, the New United Motor Manufacturing, and as president of Ydatum, he has led organizations from Fortune 500 to minority companies in the design and implementation of industrial engineering and business solutions, with documented savings exceeding $2 billion. Thank you very much for coming. Everybody give him a round of applause. Yep. Thank you very much. Thank you. We also have Malcolm Knapp, who is one of our wonderful mentors here in our community. Long time. We've known him for a while, and we're excited to have him up here. He is an independent product management consultant with over 15 years experience as product manager, engineer, and instructor. And he is the creator of the Orbis Analysis, which is a new framework and process that enables engineering teams to create hardware MVP in 3 days. I want to thank you as well. Everybody give a round of applause for Malcolm. Today we're going to do a little kind of a panel discussion, and then we'll take some questions at the end. At the end of or at the top of the hour, around 9 o'clock, at 8 o'clock, we'll do a speed intro, and I think we'll probably tap Bo wherever he is to help organize that as well. So you get a chance to talk a little bit about what you're doing and network and everything else. So let's start off with, I'd love to just start first, congratulations on your book. You just recently published a book, The Toyota Economic System, How Leaders Create True Prosperity Through Financial Congruency, Dignity of Work, and Environmental Stewardship. And in it, you explore the principles of the Toyota production system. Right. Could you share how some of these principles can apply to startups and kind of particular where they fit into an early stage company?
Absolutely. So actually, what's interesting is that today the Toyota production system is used throughout the world for companies that are already big and have scale. But what we have to remember is that Toyota actually created the Toyota production system because they did not have scale. They could not compete making a car in Japan against the big three of the US, GM essentially, and then Ford as well. So everything in this book actually applies very well to a startup because it's all about not having scale yet and focusing on eliminating waste instead, right? So that's first. The second thing is that it provides also a path to understand that how we organize work is extremely important. Most of us in society, and thereby the entrepreneurs as well, we think of products when it comes to progress in society, right? If you really think about increasing the living standard of people, you think of the product we've made. But the reality is that how we organize work is equally as important. As a matter of fact, there are 3 production systems that were ever invented. That's the first one was craftsmanship from the 6000 BC, first civilization. I'm not an historian, all the way to the 1700s. And then in the 1700s, because we begin to harvest energy and better technology, we have the mass production system that starts, right? And how the work is organized has influenced our society tremendously. If you think of the mass production system, just from a labor relation point of view, the birth of Marxism is because when we switched from craftsmanship, where people had an expertise, to the mass production system, where people no longer had an expertise, we see a dehumanization of work and labor relation conflicts, the birth of unions, and the geopolitics we find ourselves in today, with China on the right and Russia on the left. So the reality is that product is extremely important. We have to have a product, right? Because if you don't have a product, you don't have a revenue, correct? The product is your revenue. But revenue is only one thing. You also have to make a profit. And profit is revenue minus cost. So the cost of making that product is very important because you may have a very good product, but if you can't make it at a given cost, you don't have a profit and you don't have a company. Or maybe at the beginning you have one because your product is so good you can call for a premium on the price. But very quickly, all products go back to being a commodity. So you got to control your cost early on. The second point is that in addition to making a profit in a company, you also have to have cash flow to pay bills on time. And that's related to lead time. So how you design your product for manufacturability so that you are able to make a profit and for short production lead time so you can make payments, payroll on time is essential. So to conclude here a little bit is that we tend to think of products. And it's very important to have a good product, I understand. But as an entrepreneur, you also have to look at how your product will be manufacturable. Because if you don't, you're going to get into big cost and cash flow problems.
Malcolm, you do, your Orbis analysis framework is really kind of developed to tackle some of these problems like how do you all of the hidden unknowns while working on that being able to control your costs and all of that comes from discovering those unknowns, those secrets of like how to be able to do all this stuff. What do you find that are some of the hidden unknowns that kind of the startups overlook when they first start with manufacturing?
Yeah, so when manufacturing, I mean, part of it is that it's actually manufacturing is the unknown in some ways. Going back to this is that people get really focused on, as they should, producing a product that meets the needs of the customers. But then they get to something, they validate that, then they get out, and then they say, okay, now we need to make it. And by that time, a lot of times it's too late you've locked in so much of the architecture, the design, that it's too late to adjust and the cost of change is really, really high. I think that, so that's one of the fundamental things is just leading you to those questions early on. And this is what Orbis analysis really does, is that it looks at the full functionality of your product and will sort of allow you to explore that design space. And that design space includes how do you manufacture it. You'll end up with all the different components, different features of your product. And one of the questions you will always ask is, okay, eventually this will have to get made. How do we do that? And by doing it in an early on state, you can bring that in early enough and really tailor your design so it can be manufactured.
Question for both of you guys.
Yeah.
Give me an example of a startup that has taken some of your advice and kind of implemented that and how that changed their direction of flow.
Okay, so again, let's go back to I talked a little bit about the labor relation, which is very important in the mass production environment. But let's talk about the financials a little bit. In the mass production system, when you try to scale up, there is always a conflict between profit and cash flow. And one of the reasons for that is to be able to achieve scale, to reduce costs, we make in big batches, meaning more than one, big lot size or big batches. Right? In pharmaceutical, you have to do, for instance, a clinical trial with a certain quantity. Or when you borrow a press and a tool from some company that's making your product, they're going to tell you if it don't run 1,000, it's not going to be cost effective, right? So what happened is that to reduce cost on one hand, you end up having to compromise cash flow on the other because batch production increases lead time. Lead time requires inventory, it ties up your cash, and you don't have the cash flow to pay the bills. So that's a very important point of it. So how do we avoid that? Well, we design a product and a process, in some cases, even equipment or tooling, right, that has a quick changeover, for instance, right, that can be easily changed over from one variety to another because products, they don't come in just one variety. Maybe your first product would be one variety, but pretty quickly you're going to have some additional variety because different features in the product, right? So how do you design your product and your equipment so that you're not hostage to that batch production? That's one example, okay? There are a couple of other examples, but I'll let you go for it.
Yeah, so an example of Orbis, I worked with a medical device company, and they had a validated technology, but they basically had a picture of a product that looked sort of like what they thought their product was going to be. And in 2 weeks, we went from that to a fully fleshed out, fleshed out model of their system with a complete functionality. And in that process, we discovered that they combined two of the enclosures that they had originally thought they needed. And by doing that, it saved them probably like, $50,000 in a couple months of time to do that extra mold work, and all that other sort of work was figured out within the 2 weeks, in the first 2 weeks of their whole development of their product. So
that's very much product related. I am not a product guy. I am totally agnostic to what you make. I really don't care whether it's a pharmaceutical product or automotive product or electronic product. Yeah. It's all the principles are very applicable to any kind of product. But you're right? If you can basically try to have less components and not having to design as much tooling is very important. Mm-hmm. My specialty, my expertise, if I can say that, is really on how you organize the work and design the product so that when it works with the machine or the labor, it's very efficient. So changeover time is one of them. So another one, for instance, is how do you decompose your product so that when it's being assembled, when you build your product in your mind or on the testing phase, development phase, when you decompose it sufficiently so that in manufacturing, we have the option to assemble this product in small increments or elements of work. And the reason for that is because the smaller the element of work, the more flexibility you have to organize around high labor efficiency. Now, labor efficiency is very important. Actually, it's the most important thing because there is nothing more expensive than labor. At Toyota, and I'm not sponsored by Toyota, I'm not endorsed by Toyota. I just happen to have worked for Toyota for many years and learned from the people who created the system and really fell in love with it. They say that the only cost you have is actually labor. And you have to think of it in terms of the supply chain. Only people get paid. Machines don't get paid, right? People that extract the dirt from the earth to make the metal, to make the machine, along the supply chain, it's all people because of work, intellectual properties, or whatever it is, right? So the idea of being able to organize around labor efficiency is very, very important. You can't just think that it doesn't matter, we'll do it later in a cheap country. Because then now you got to be dealing with logistics and all kinds of issues in communication and all that. So how do you decompose your product in small increments, sufficient small increments, so that when you are building it, you can have a same amount of work for everybody and a single pace of production. So the three elements of actual continuous flow, which is much better than batch production, is zero change over time and the same pace of production at each process of the assembly process, at each of the manufacturing process. Okay?
Yeah, I want to add into that decomposition, because this is exactly where Orbis analysis helps you, is that it gives you that decomposition up front. You can actually start seeing it works as in a hierarchical sense. Most products are built up of, there's the car, and then there's the powertrain of the car, and then the engine, and inside the engine there's the pistons and all sorts of stuff like that. So you have multiple scales. And what Orbis analysis does is it allows you to view all those different scales all at once and break it down, like I said, within this sort of upfront. You will already know this. If you wait till we even getting to CAD, developing full CAD models of your whole system will take time. And so you still are already stuck with your architectural decisions by that point. But with Orbis analysis, you can see that decomposition upfront. You can start thinking about, when you bring in manufacturing early on, you can start thinking about, okay, how do we make this equal? How do we break out this work in an actual manufacturing line?
Very good.
I see that, you guys, one of the things we see a lot in our community is people are bringing their products to market. Of course, design for manufacture. That's the thing that everybody skips.
Yeah.
Everybody skips it. Nobody wants to pay for it. And it's one of those things that it is crucial to getting your part to that. So to be able to have operational efficiency, to be able to design your part for different types of manufacturing lines. And I think it's one of the skills that I think our community often doesn't have, or they're a lot of times for not as wanting to pay for it. And it is so crucial for that step. Kind of in what you guys know and where you're going with design for manufacture, where do you see in the stage that they should be really applying that? And I mean, I have my thoughts on this, but I'd love to know about where in their process do they need to be looking?
So the simple thing is as early as possible.
That was my answer.
But for me, I have a slight caveat to that, which is you when you're in your process, you do need to validate that you have customers, and you need to validate that the core technology that you have performance that's required. And so what I say is actually move it down the chain a little bit. But the moment you have validated that your technology is working the way you expect, and you can have a path to the performance you need, that's when you bring in the sort of third pillar of product development. I really view it as equivalent to customer development, to product development, there's manufacturing system development. And you should be assigning a person to it, like a third co-founder sort of thing. But you do it after you've validated your performance, after you validated your customers, and then you start immediately. It's sort of like the DVT phase is another way to think about it.
Yeah, very good. I agree. As an entrepreneur, I mean, I am part of a couple of startups, so I know how it works. And when I'm with a company that actually makes a device that harvests plugs in the skin for cosmetic, reconstructive, and also stem cell harvesting. And so when we make the product, because we are founders and part of the company, we are willing to work hard and take long hours and use our skills to actually build it. Mm-hmm. And so it's a false feedback, because once you try to make it in large volume, you're going to go and hire somebody that doesn't have your skill, doesn't have your patience, doesn't have any of what you bring to the table. And this is when you figure out that, well, we can't do it the way we designed it, or we cannot do it efficiently. Actually, I should rephrase that. You will always be able to do it. That's not the problem.
Yeah.
Being able to do it is not the problem. Being able to do it at cost with a reasonable cash flow is the challenge. And we have to think about that as early as possible.
Where do you guys see, I've got a whole bunch of questions here, but the one that gets to me, that from my own personal experience, I mean, I manufactured a product, and I found when I went to go look for sourcing, the way that I did is I just literally had to go to manufacturers, show them my product, and get quotes, and it's showing up. Things have changed a lot since when I started with this stuff. And my question to you on there is what are some of the kind of trends now that are emerging in manufacturing that we need to be aware of? And as well, where did that relationship building with your manufacturer begin, and how do you navigate some of that?
Well, there are a lot of trends because of technology evolving all the time. Like the 3D printer is a very good example of that. Okay, where before prototyping was very expensive. Today with 3D printers and with digitalization of the CAD of the design, that makes things very easy. But I am not so much of an expert at that. What I would like to say is that it's very important that very early on we understand not so much how we're going to leverage technology, because technology is here and you can leverage it, but how we are going to be able to do it simply now. Let me give you a simple example. For instance, you design a product and there is some molding, some injection molding, to maybe build some sort of a shell around the product, right? Well, that injection molding then is going to require probably a mold and maybe a press to do it, right? And so what's going to happen is that when you go to a CMO or a manufacturers, they're going to tell you, well, this is my equipment, my press, and if I'm putting my tool into my press, your tool or the tool you design into my press, then I'm going to have to ask you for a certain minimum quantity so that it's worth the time I'm taking to actually put the tool into the machine, right? And there is a big problem because you don't need a big quantity. Frankly, you are still in design, and maybe you want just a couple, and then they're going to charge you a lot for doing just a couple. So my advice to you is actually stay as simple as possible. And I'm going to exaggerate a little bit, but when we prototype at Toyota, to be honest, okay, we use cardboard. We design machine with cardboard and tape to know how to organize the work. We sometimes make a clay. We make it by hand. We really are as simple as possible because what we want to do is get feedback as early as possible, because the earlier you get the feedback, the more you learn about what you don't know. It's not so much about learning about what you need to know, but what is not going to work as well. And there are a lot of books on that, actually. Steven Spears, I don't know if you heard of him, is great. Just came out with a new book right now. It's available right now. It's called Wiring the Winning Organization. Very, very good book. And but anyways, one of the big principles is to try as early as you can, okay? And so sometime when you go to a manufacturers, they'll show you all their technology and all their investment and how you can use it to be better, but you have to be careful about that because it can really lock you into disconnected processes, big batch production.
Yeah, I would sort of piggyback on that because I've actually seen some interesting where startups themselves are actually taking on more and more of the production of their systems, especially at this really small volume, at a couple hundred units, with robotics and other sort of these higher technology systems. It actually is a bit of an opening to bring it more in-house. And many robotics will do final assembly, for example, in-house, versus going to like the standard, go to China, go to a CM and get everything done, and you just get the product, shipped to you. And I think that this is actually something that is the relationship you have with manufacturing. It is essential, we've been talking about it, it's essential to your success. And so bringing it in-house is one way to approach that, and taking on that responsibility. Yes, it's more work, but then you have complete control over it. You have complete understanding of the process as well. And this is one of the biggest things, is that you'll get a quote back from a manufacturer and you'll have no idea why it's that, Whereas if you built it in-house, then you actually can probe that and you understand what's going on. You can actually understand if you're getting a good price or not. And so I think being okay with taking on at least initially that part of the work, and then you have much more knowledge to go to external people, what information they need to see. And then when you do that, treat it like a relationship. It's not like a vendor, going to get your car washed, where you just roll up and they do it. You're in constant conversation where they are investing in you as well because they want you to be successful. and they need to get they're trying to make money as well. And so you have to treat it like that partnership. That's where I'm on that.
Bring it into the house.
Yes.
Expand
Yeah.
your company into the manufacturing to really understand how to manufacture it is a very good.
Yeah.
I think it's something that we've seen a lot in our communities is that as you go those relationships with people, like we're an open ecosystem. We don't want to like shoehorn people into one particular production line or supply source, and I think that's an important part. And where I think a lot of our previous incubators in the hardware space have fallen because they're like, hey, we've got this great supplier, we've got this great manufacturer, but those relationships aren't one size fits all with startups. And I am seeing more and more of our companies doing a lot more of their micro manufacturing and beginning, even at higher costs, of course, at first, because then they do have that control to be able to get that out.
You should be really thinking like that your manufacturing system, you're prototyping it the same way you prototype your product. And having to prototype that at some remove where someone else is prototyping it and you just see little bits and pieces of that, it's just that much harder.
Absolutely. So Olivier, I've got a question for you on how can startups, one of the things you worked a lot with is the lean manufacturing. So how can startups implement lean manufacturing practices from the very beginning, and what are kind of those immediate benefits?
Well, so very early on, when you start designing your product and maybe the equipment that you need to build the product, you have to use the technique of what we call standardized work. I don't know if you're familiar with that, but the idea behind standardized work is to document the work in detail of how it's going to be manufactured. There are three elements of that. There is a sequence of the operation. There is the pace at which it needs to be produced, and then there is the third element, which is the standard in process stock. Where is it's not inventory, where is the minimum amount of material going to be located so that we can continue having a smooth flow. So what I'm saying here is that we really need to take a pen and a pencil, a piece of paper and a pencil, and draw almost by hand how we're going to manufacture this, how we're going to make it, and what will be the relationship between the person making it and the machine if there is one. Let me give you a very simple example. If you go to any manufacturers, not any, but 90% of them in the country, right? You will see a machine and typically a person standing in front of it while the machine is cycling. Well, you have to ask yourself the question: if I have a machine doing the work, why is a person standing in front of it? Because the idea of having a machine do the work, beside the fact that there is safety and maybe more efficiency in the machine, the idea is to transfer labor cost into machine cost. But if you still have a person watching the machine while the machine is working, where did you remove the labor cost? And if you go to manufacturers throughout the country, throughout the world, you're going to see people standing in front of a machine, working automatically, doing nothing, just basically babysitting the machine, making sure the machine, or pushing a button. But pushing a button takes a second. Right? It doesn't take 30 seconds of just doing nothing, waiting for the piece to come. So what I'm saying is, very early on, is really understanding how the labor will work with the machine, and the machine with the product, and the product with the labor, and the product with the machine. Mm-hmm. All that trio there. Yeah. And documenting it through a very simple techniques called the standardized work chart and the standardized work combination table. Okay?
Yeah, I mean, so just to sort of piggyback on that, this is, again, where Orbis analysis comes in, is because one of the biggest things is thinking about this. I mean, the example is the assembly process, the sort of sequence that you're going through. In any system, one of the major ways of looking at its functionality is by its behavior, how it acts in time, what are the steps that you go through. This is very simple if you're thinking about like a robot and like, how do you actually get it to move from A to B? What is the first thing that the user must do? But in manufacturing, it's like, what is the first thing that what is the first step in that? What's the step after that? What's the step after that? In very simple terms, you can sort of map out all the things that you do, and every single step must have equipment or tools that allow it to happen. And so again, you get this cycle that allows you to flesh out everything that you'll need very, very quickly and get to this sequence that will make your product.
Let me give you some numbers just to clarify what I was talking about.
Yeah.
The best labor efficiency you can get right now, the world-class labor efficiency is about 78%. It's Toyota assembly line, 4 workers, all working at 100% or 98%. There's a reason why it's 98%, because if it's 100%, we don't know if there is excess labor. So Toyota likes to kind of challenge the process, right? But anyways, for every 4 workers in a typical process, there is 1 team leader. So you've got 4 people at 100%, 1 at 0, essentially. So the average of that team of 5 people is about 78 to 80% labor efficiency, right? That's the world-class benchmark, okay? If I use that benchmark world-class as a datum, most companies in the US, throughout the world, let's start with the US, they don't even touch the 40% labor efficiency. Probably half, right? 35 to 40% labor efficiency. It means that half of the labor they have, they don't need it. And labor is very expensive. If you go to developing country where the labor cost is cheap, like Mexico, for instance, or inexpensive, or other countries, then there's complete disregard on the part of management for the labor because it's not expensive. The labor, all of a sudden, it becomes the second problem. The machine has become the first problem, right? The labor efficiency is probably 10%, 15%. So what I'm saying here is that when we don't do a good job up front, we can observe, we can see it. We can go right now in manufacturing companies in the US, and we see labor efficiency at best, okay, being in the 50% after people have implemented a bit of lean into the production system. The average is probably 35%. Okay, as a matter of fact, I will not tell you the name of a company, but I was just working with a company, large scale, big, okay. We started the job 8 years ago with about 350 people. 8 years later, right now, we have half the labor. And so basically, EBITDA went from roughly 7% to about 17%. Okay, so it took 8 years because we don't want to lay off people, because it takes time to engage the workforce, make the expert, work with them. So we use natural attrition, right? But the reality is that there is not a better method for guaranteeing full employment and also a solvent company than having a labor efficiency that is high.
I want to come back to that in a minute, but first I wanted to talk. So we're talking a lot about processes and being able to put that in standard as work and being able to plan out a lot of this design for manufacturing. I've gotten an opportunity to kind of see Orbis in action, which has been really cool to that. And, it's all of these processes are hard to understand, right? And I think that we kind of have an idea. There are a couple other processes like waterfall and agile that I think people know. Can you tell me a little bit about like kind of how Orbis is different and what those, like how that all kind of, what are the advantages and disadvantages of those kind of outlooks versus what you're doing?
Well, it's interesting because waterfall and agile are ways of basically sort of managing the engineering work itself. There's sort of a project management methodology. I call Orbis analysis a product management methodology. So it's about figuring out what you're making versus how you organize the making of it. And so what you can think of is that in agile you're based around a 2-week sprint going, and you're going from abstract down to something very concrete. You implement it. In Orbis analysis, you're thinking about it more as a horizontal sprint. You're taking and looking at it's one phase of the agile process. And what you basically do instead of going from abstract to concrete is you look at a 360-degree view of your entire system. So it helps, it's sort of in the planning phase of an agile process. It's basically you will revisit the model you make in Orbis each time you go through that process to help you plan the next phase of work. For waterfall, the sort of EVT, DVT sort of cycle, it basically takes the place of requirements gathering and architecture. Both of those are intrinsically bound to each other. And when you are done with that process, you end up with a set of sort of engineering templates that allow your engineering team to just execute. They don't have to sort of stop and wait and come back and say, what about this architectural question? Because those have already been engineered and figured out in the process.
Very good. Yeah, I mean, if I may add, there's good news, though, because there are kind of two types of problem solving. When you design a product, there is a problem, which is, hey, how do I make my product perform? You're designing something that probably has never been designed before. So you are going to try to solve a problem with very many unknown parameters and problems that you have to solve, for which you don't know the answer. The good thing about the Toyota Production System is that unless you want to contribute to the discipline, which is not your problem, you shouldn't try to do that, the answers are known. It's actually pretty simple. We know how to do it. We know how to do it. We know that disconnected processes create long lead time creates inventory ties up your cash, you won't have cash to pay bills on time. So don't disconnect your processes. The principles are actually very well known if you learn them, if you know them, right? So the good thing is that, for instance, if you design a piece of equipment where somebody has to babysit it, as opposed to be doing something else. In other words, if you design a piece of equipment without what we call standard in process stock, meaning that when the person comes to the machine has already ejected the product, and all you have to do is load the new product, pick it up and leave, and start the machine and leave, right? And so you don't have to, so we know those things. It's just knowledge. It's actually not very difficult knowledge. And so it's a very different thing than building a product for which you really don't know, it's very unknown what you're trying to solve. In manufacturing, if you know the principles of what you're trying to achieve, it's designing for them, essentially.
I think we, as a startup community, I think a lot of times we have our blinders on, right? I think a lot of our companies, the engineers, we're getting excited about building our product, and then that we don't actually think outside that box and say, it's like, these are known processes. And I think one of the reasons we as a community here have come together is like, hey, battery certification, FCC certification. These are things that someone else here in the room has already done, and we can talk about it. And I think we need to reach out beyond our bubble, reach out, in these kind of groups, connect in our networks to be able to understand. Because a lot of these are solved problems. Manufacturing is a solved problem. And I think a lot of times startups are so used to working unsolved problems that we just think that maybe we have to reinvent the wheel every time. But with manufacturing, we don't. And
we actually don't like to do that. We like consistency and boring.
Yeah. So I've got one more question for you guys before we do a Q&A. And kind of the beginning of stuff is like, in your experience, what are some of the biggest misconceptions startups have when they begin manufacturing and the resulting pitfalls? Malcolm, why don't you go first?
I worked in sort of electronics manufacturing, and one of the biggest things was the data that we would get from startups. That manufacturing package, in some ways, it's just, you've already done all the work and then you now need to make and export data from that to give your manufacturer what they need to actually produce the product. The data quality of that is extremely important. This is one of the biggest things that causes huge delays and actually products that are made wrong completely, or made that are said to be unmanufacturable. Because paying attention to that package, that is actually your job as an engineer. Your job is not to make the product, because you don't do that. Your job is to make the documentation that makes the product. And then you give that to someone else who then will do that. So your output, you solve the problems, you figure it out, but your final output is that manufacturing package. Really pay attention to what that looks like, really make it clean. Yeah.
We'll be to 1 second. Let's open up the hold your thought and we'll come back to that, okay?
Yeah.
Well, I think one of the biggest misconceptions, maybe the data is telling us, right, is that most company fails because they don't have the cash flow to continue. So the reality is that not thinking about the importance of manufacturing early on but only thinking of in terms of revenue because the product is good is a mistake. Your product will go back to being a commodity pricing because it's going to be a commodity within a few months. And if it's not the commodity pricing that gets you in terms of the profit you're making, it's going to be the cash flow because you've got long lead time and not enough money to pay bills on time. Okay, so I do think that the biggest misconception is not to consider the financial holistically, right? The income statement, meaning the revenue, yes, the good product, that's great, it's important. I'm not dismissing that, okay? But the cost, we got to pay attention to the cost and the cash flow. And those are very important financial statements that every single company has to use. It's called the income statement, statement of cash flow. There's a third one, right, called the balance sheet, which the bank love because they want to see your balance sheet to loan you money, okay? But borrowing money is expensive. There's nothing that beats getting cash from operation without having to borrow it. So essentially, that's a big, and that's where companies fail.
Excellent. If you guys don't mind, I'd love to open it up to questions and start from there.
Yes, please.
Yeah, awesome. Let's go ahead and start here. Before you start, here you go.
Yeah, for this previous thing you said about a minute ago, like saying like as an engineer, you're not supposed to be designing the project, but you're supposed to be designing the documentation. So the other person could design the product, but as somebody designs the documentation, does it like involve any blueprints or instructions or what exactly?
So, I mean, this is what does your manufacturer actually need from you is a really important question. I mean, there's a lot of detail. I mean, if you're talking about electronics, mechanical systems, they need different things. In general, I mean, one thing to be precise is when I say you're designing the product, and then someone else makes it, so you have to clearly communicate your design intent.
Okay, that totally makes sense. Especially it resembles what I'm currently doing right now, because since I'm currently doing an internship for 3D printing, and I even brought my products here just in case anybody might want to see. But one way how I really generate or design the products is following blueprints. So depending on different structures or different parts of the product, like you need to know like the size, like how many inches or how far of a distance as you're dimensioning. And then what's going to be the final outcome once you're all finished. So that's definitely stuff I'm learning just about every day now.
Yeah, so generally the quick categories for mechanical systems are the CAD itself, there's manufacturing drawings, then there's also one of the biggest things is the quality specification. What is the actual allowable like tolerance bands? And to know if you made the part correctly or not. And then you can go from there. There's lots of detail there that you can get into.
But do they make anything like blueprints or anything?
So when you say blueprints, what do you mean by that?
Kind of like the instructions you need to follow as you're making the product.
So you're talking about the actual like fabrication instructions?
Something like that, because they might draw an example for how it looks like or how it's supposed to look like, and then the instructions for what to do to make it look exactly like that. So you're just following the blueprints. Yeah,
so we can talk offline about that in more detail, but there's also, if there's like special instructions, there's a lot of times notes and things that what people will give you. But part of this thing is that there's no standardization here. And so you have to work it out with your manufacturer exactly what they are looking for. But do spend that time is the key thing to take away.
So the question is very interesting, and I like the question because in Toyota thinking, for instance, right, we have two big kinds. Yeah, I'll get closer. We categorize the information that's required in two big buckets. One is what we call the work standard, and this is everything that Malcolm just talked about. But the other one, and the one we have a tendency to ignore, is the standardized work. And so to make an analogy, for instance, the work standards, everything that Malcolm just talked about, would be whatever has been legislated in society. So it's the law and the rules. In other words, the product has to be that dimension and that dimension to fit and to perform correctly and not to be a liability on the market and to actually do what the product is supposed to do. Okay?
Yeah, like, especially when you're making dimensions, you need to say like...
That's right.
Yeah, especially when you're indicating dimensions, like you need to
Right.
indicate like how far of a distance from the top part and how far of a distance from the
Correct.
left part or the right part or the bottom. So like saying like how many inches, sometimes it's usually a little less than an inch. Like when you write, say if you draw like one dot and another dot and how far apart they need to spread apart from each other, or like, and how far of a distance from the top and how far of a distance from the bottom.
Right.
So that's one method of dimensioning.
Right. So everything you're talking about here is product quality, product performance. It's about revenue. It's about the work standard. It's about what's been legislated in society, to make an analogy. But the other half of it, which is extremely important, is how is the work going to be organized? And that's the standardized work. It's the movement of the hand, the movement of the feet, the relationship with the machine. Okay, and those are all of the things that are not legislated in society, but that is customary, part of the culture. Opening the door for an older lady, giving your seat in the bus, right? Contributing to the fund for Christmas, whatever it is, right? And so we tend to think about everything that needs to be legislated or documented according to a CAD, and we tend to completely forget about how we're going to make the product quickly, because when you're in manufacturing, if you start opening the drawings to know what to make, you're done. High volume, you can do that. Your worker cannot be opening the documentation to figure out how to make things. He's got to know it inside out and do it almost instinctively the way you drive a car.
Yeah, I mean,
Please.
oh yeah. So I want to, is that this is actually something else that is for, like, a lot of times it's the assembly process for a lot of hardware systems is this sort of the organization of the work. And one, I think, misconception is that a lot of startups think that the manufacturer will create that. But no, because your manufacturer doesn't know how your product is or how it's put together, you have to create the assembly process, at least the first version. And then you can give it to someone else if you go outside, and then you make it better and make it better. But that first version, that first organization is up to you as a manufacturer, as you as the startup.
And the quality of your documentation, of course, is the quality of how well your product is manufactured.
Yeah, exactly.
It's kind of where we see in Mech Labs, for example, we do a lot where it's like, you have to document yourself, but we do it as a tutorial so that it's covered and you're actually having to explain it. Because I think engineers often, we document just by like, oh, these are my notes, but that note is useless until it's put into process and it's actually created for our manufacturers. Yeah. I'd love to open up a couple of questions.
So I want to really say something. One more. So two things, right? Exactly what you just said. How do we manufacture for quality? But the second part of it is how do we manufacture for efficiency?
Yep.
And typically, there is zero documentation on that, let alone the documentation that is formalized and standardized and validated by engineers. We don't need to validate it by engineers, but at least have some semblance of how you're going to do it to be efficient. Okay.
Yeah. Absolutely. I wanted to grab somebody in the back here. Here, let's start with you. There you go.
Thank you so much. Hello.
Hello.
I'll stand. So I work for another local hardware company. We make a robotic plant wall that takes care of itself. So it's got a hardware component, it's got a software component, it's got a greenware component. Those are all different. But we are kind of a mature company. We've been around for a little while, and that means that we are just getting to our first round of contract manufacturing in Thailand. It's coming up next year. But we just figured out, like last week, that it's probably time for costs down. And 125 of the plant walls are coming as is. What would you advise we should do to transform the product from that held up inventory, just like you said, to the cost down version as soon as we can?
Well, I mean, so thank you for validating everything we just said. With a real case example, I don't know your product specifically, but the approach would really to go on the shop floor and begin to work with the people responsible for making it, and then with a set of filters, which knowledge filters, meaning a set of parameters, just like a mechanical engineer or a doctor would do a diagnostic, like a medical doctor would do a diagnostic, is to go on the shop floor and begin to see where is there waste. and the waste are organized in, there's 7 wastes in the total production system, sometimes 8 in lean. But there is overburden and unevenness and then the waste. And so you begin to do a diagnostic through actual visual, grasping the current condition and documenting in terms of cost. Okay, so that'll be the first step. Okay, and from there, take whatever action that's required. What I would be very careful about doing, you're not in high volume manufacturing yet, are you? No, because make sure that you really engage the workforce. And I don't know what kind of workforce you have, but don't do it in isolation without the workforce, because at the end of the day, they're the people who are going to make your product, right? So their expertise is very important, and bring them along with you.
Yeah, I mean, I think that, go to Thailand, basically.
Oh, you in Thailand?
Yeah, yeah. Okay. This is what I mean about bringing the manufacturing inside. So even if you are, the expertise and the equipment is, your partner, you have to bring it inside and understand it yourself, because otherwise you just don't know. And being able to actually see the process and see what part of the assembly, the way the design is, that's causing them to spend 5 minutes putting it together and it fails. You only will know that if you're there,
Excellent. Questions? I think start here.
Thank you. When you talked earlier about designing for manufacturability as early on as possible, that makes so much sense, right? But how do you do the trade-offs when you need to be very versatile, especially in those early days of a product, right? Like behind you got a robot that looks like R2-D2, and you got one that looks like a dog. What happens if sales comes up and says, I need the dog head on R2-D2, and you got to change like that? How do you balance those trade-offs?
What I would say is, this is what I was saying earlier about you want to have a certain amount of convergence. You want to have validated that you have customers for a product for a certain performance before you bring in manufacturing onto it. So you can't be at that stage where you have these 2 radically different architectures. You need to do some validation, and then once things have converged down, then you may still have changes, but you won't be radically sort of pivoting to a completely different product at that point. So, the thing you need to do is just, that's too early, and you need to wait a little bit. You need to get a bit more sort of further down the line to bring in the manufacturing, is what I would say. Yeah.
So, very good.
Yeah.
So I'd like to add to that a little bit. With the connotation of the Toyota production system, there are a set of principles and philosophies in the Toyota production system, and one of the very important philosophies is the philosophy of total versus individual efficiency. And this philosophy is important because it's the guiding principle by which we actually run the company and design products and so on. And what that means is that you cannot just go after one parameter at the expense of the other. In other words, if you have a set of criteria that are solid in front of you, and you start to compromise one at the expense of the others, then you don't move forward until you solve the problem. Because otherwise, you only have half of the solution. So what I'm saying is that the rule that your company has by which they obey is the discipline that forces you to get better at what you do. As opposed to say, well, I'm going to compromise that because marketing wants it, and then I'll pay for it later. So there's a very different set of principles and philosophy here, which is, let's not try to make a profit now at the expense of bad later. Don't displace cost. If you work in an environment where cost is displaced, as opposed to eliminate it now when you can, then eventually you're going to be in trouble, because trouble is going to come. So I hope I'm being clear. Right? There's a very strong discipline that's required. And frankly, being in a startup and being innovative about a new product is difficult. You got to rack your brain. In other words, you got to impose yourself a set of disciplines that's going to make you rack your brain better, more, and harder. That's what's going to separate the successful people from the ones that are not successful.
We have time for just a couple more questions, but got one here.
Yeah, I have one that actually might be a different point of the phase and might benefit everybody here, but I'm happy to talk more offline. But let's kind of strip it down. We're a company that's 7 years running. It's been entirely bootstrapped. We have not taken any outside investment. We're cash flow positive. Initially, we are a heavy hardware company. And in the first, call it 6 or so years, we were mostly building the hardware to establish and grow a market that was not yet really firmly in place. Now that it's starting to kind of get into the next chapter of the market is sort of starting to grow on its own, we've already gone through the process of the hardware we make, gone through the QC process. We've brought costs down. We've reined it in. We've got logistics fulfillment. So a lot of the challenges that ultimately you need to get to start to go to scale, we've achieved, which is amazing. But now we're in another challenge, which is as the market is trying to grow, we want to chase and continue to build upon the momentum. We're running into the situation I think we all have, which is you still have to put a high cash flow outlay for the hardware inventory that you're building, which continues to climb as things continue to blossom. So the question I really have is, when you're at that point, what are some of the alternatives or perhaps things that you guys went into to find alternatives to helping finance some of that inventory outlay, without necessarily, all of a sudden now half the year you're sort of crunching because the cash is out tied up in manufacturing or inventory.
You're talking specifically about inventory, not equipment, not buying equipment type of.
Right. So because we've already gone through the challenge of getting those prices down. So we're really happy with where we are in terms of like making
Capital.
10,000, making 50,000.
No, but no, the capital, the machinery. It's not a machinery.
It's not about, it's more about just the process to finally get finished goods so that we can then continue to serve the customer base or drive revenue.
And your big issue is that in your supply chain, you basically are forced to buy in big quantity to get a reasonable price, but it's tying up your cash flow. That's what you're saying.
Yeah, now that we're maybe bringing on new partnerships or new opportunities that are going to ask for a much larger volume of the goods the hardware that we produce, the question then becomes okay, aside from the partner perhaps providing some of the upfront cash necessary to do that, like how else could we find ways to sort of thread that needle so we can still deliver on the larger demand?
Well, it's very much of a financial question, more than a manufacturing question. But what I would say is, my advice would be to not work to a forecast that may or may not be there. In other words, think that if you're working to a forecast that's telling you to buy this quantity, and there's a long lead time between the realization of that forecast and the time you buy that big quantity, I would be more conservative. Because forecasts are just forecasts. They wouldn't be forecasts if they were not forecasts. They would be called something else. They would be called firm demand, okay? So I would be staying within the capacity that you have of funding it. And even if you miss a little bit on sale, because there's the greed that comes in, right? And the greed is very enticing, but there's a certain level of risk because of forecast. And I would be careful about that. But without knowing more, I can't say anything.
Okay, we got time for one more question. Let's go right here. And then we're going to open to the speed dating or speed intros. And so if you guys are interested in doing your speed intros, come line up on the side here too, and we'll go through that in just a moment after this question.
Thank you very much for the talk. So you mentioned one thing in today's modern environment. If you have a product, China will come in, they'll replicate it, they'll do it cheaper, they'll do it faster. And are we just resigned to that fact, or is there something that, as a product designer or creator, you can do to keep an advantage on that front? Or do we have to, look at other areas to keep a, advantage in the market?
I mean, I think what's interesting is that there is part of this is that, this is what Olivier was saying, was that eventually you're commoditized, and that'll happen. And so it is sort of, you're always on that treadmill a little bit. I do think that there is some interesting, with the higher complexities of like robotics, for example, that are actually don't go to China necessarily. And there's some sort of interesting opportunities in sort of product categories like that. But, this is part of the thing is once a product's out there, people can see it. And if it's successful, people will want to try and copy it. And so you have, that's always going to be there. And that's always going to be a pressure.
Yeah, I'll be very severe on my answer. If we knew manufacturing, we could compete. We just don't understand manufacturing. And I'm not saying the people in the room, but in the US, in Europe, we don't understand manufacturing. We're not efficient. Most companies are 35% efficient. If I go to a big pharmaceutical company, they're 5% labor efficiency. So once you start being labor efficient and you don't have to pay for the logistics and the complexity and the errors and the scrap coming from China and the last communication, you actually can be competitive. I believe we can.
Yeah.
We can. We just don't understand manufacturing sufficiently. Manufacturing is difficult, it's demanding, and we need to understand it if we want to be a country that can do it well here.
Yeah.
And we should do it.
I want to jump on that as well, because I think there is actually an opportunity for startups. As I was saying, I'm seeing more and more who do in their own manufacturing. And in the US, startups doing their own manufacturing, they're starting with this sort of, they can redo the process of that in the way that works best. Whereas if you go to a US manufacturer, they have their way of doing it. They've been doing it for 30 years, and they're sort of stuck in that way of doing it. And so I think there is this new opportunity for startups to actually get to that point of being efficient in manufacturing and getting to the point where they really can understand it. And that can really help bring manufacturing back sort of, it's in the new form. There's opportunities there as well.
Thank you guys, everybody. Thank you very much for everybody coming today. I appreciate. Thank you, Olivier. Thank you, Malcolm. We're going to do a little speed intro setup. So if you're interested in, it'll be 30 seconds. Introduce yourself, what you're looking for, or, what you have to offer, something about your product, or just, what you're doing. Even if it's a hobby, it's exciting. It's a great way to share, and it's particularly good for networking, because then you can just be like, oh, that person's doing this thing. I want to talk to them. It makes networking so much easier for those of us who can't just go randomly up to people and talk to them all the time. So anyway, please come on up here. Bo is gonna help us out and wrangle our thing. So come on up. And one last round of applause here for our speakers here. Thank you guys all. Thank you. Awesome. Okay.